Hello, everyone. Thank you so much for being with me today in today's session. And greet to everyone, no matter you are currently at home, working from home, or you are in the office. All right, my name is Brian. I am from Matrix Invent. We are the distributor for the Canary for this part of region. Okay, without further delay, let's get into our session today. Welcome to all the engineer and data expert, if any of you here. At Canary, you know that the engineers and data experts have many ideas of what they want to do with their data. No matter what size of the component you are having, we always have the same core requirement that when it comes into the data. Okay, a lot of time that they were telling us that they want to store everything. All right, they want to store everything. A lot of time they don't know what the data could do for now, but they want to store that in the future. They know that they're going to use it in the future. All right, and a lot of this data must be in a very faster pooling. No matter the data could be updated in an hour time, or it could be in 15 minutes or even 15 seconds. Okay, it is always a faster pooling, and the data must be made available to everyone in an organization who need to access to it. All right, and regardless, the open access is for the internal engineers or the data experts, so you could be even to the external parties such as like contractor or vendor. And finally, integrate and act the data, maximizing the potential of the operation. This is something that I'm trying to stress out a bit more. Why that is actually aligned back to our webinar session today. How do we actually using the data that is available and make it become meaningful and put it into something that visual that everyone can read and understand. All right. But a lot of time that when it comes into time series data, a lot of time all these companies that they are holding back. There's a huge problem there. But what are those key issue that is holding them back? First thing that we always heard about that is database management can leave you a very frustrated and stuck. All right, as you know that in those MySQL or SQL database or Oracle, whatever it is, all these relationship database systems, you need to have to do a maintenance on it. Either you do a re-indexing, or you could be potentially you have to shrink the database log when it's getting overloaded, and then there's a lot of maintenance over the database, and it can be very frustration, and you need to have a DBA or expertise to do that. And then you have the IT and OT unbalance, all right? Continuing of operation of a production mindset while balancing security is always a challenge, all right? So there is always an argument, I can't say it's an argument, there's always a conflict between the IT and OT, how to balance those, when they come into providing a database systems that is specifically for the time series process data. And high cost and slow ROI. All right. So I guess that some of you, if any of you have been using or reselling, or you have been, any one of you have been using some of our comparative time series database system currently. All right. I guess when it comes into the cost, it is always challenging when how do we get an ROI from it. But it doesn't have to be that way, all right? And something that Canary definitely would be able to help you. Okay, and with the Canary system, you can transform your operation. How are you going to do that? Because Canary provides the ability to collect and store the vast amount of process data. And then we can add the context to your data, make it become meaningful and relevant, all right? And finally, gives your team easy to use tools and secure databases access via organization needs. Okay, so the agenda that I'm going to talk a bit more on today will be about 30 minutes, all right? And we're going to go through some of the Canary system overview. How does it look like, and how do we, getting beneficial from using the Canary, and finally using the tools to visualize the data that you having. Okay, let us get you. We definitely can get you why we say so, because Canary have been helping engineers and organizations like yours, have been installed in 19,000 over installation worldwide, and it's over 55 countries and more than 20 different industries around the globe. Probably you heard a bit about this using a time series database, or historically we call it in oil and gas. But in fact, is that based on the Canary user database, they've been using from various industry. As you can see here, you have coming from oil and gas, and you're talking about aerospace, NASA, Philip Morris, and a lot of more customers. Okay. All right. When you always come into the data, that is always that we in the Canary perspective is that or the conceptual of an overview of the time series database always comes in the step 1, 2, and 3. And first of all is we are talking about the collect and store the data. All right. Before you go into the visualize or give it assign a meaningful context to the data, of course we need to collect, right? We need to collect the data. So Canary Connectors, all right, they help you to reach out to all industry standard protocols so that you can log data directly from your process into our system, into the Canary system, all right? Regardless what kind of a standard you're using, all right? Either you're using an MQTT Smart Plug B, which is a common standard in terms of like IoT, that today's it become very common, and it can be integrated with various of IT systems, such as you're running on the AWS as well as in the Azure, and then you have an OPC, UA, and DA, SCADA systems, SQL databases, CSV files, web and .NET APIs to create your own custom connectors too. So basically, you can almost support all kinds of industrial standards available in today. And a very typical architecture will look something like this. You have your PLC and devices to be in the field, all right? And then you probably already have an OPC or MQTT brokers, okay? That your devices are speaking to, and we install our collectors software on the OPC server, okay? Then we will build a Canary server with the rest of the software, which the client tools will connect with. And then important to note that the Canary server does not impact any of the PLC and devices, because we don't write back the data back to the OPC. Okay, and then we will, a very typical architecture will look something like this. Your PLC and device will be in the field, and then, I'm sorry, yeah. Okay, then you have a Canary historian server, and finally you have the client tools that you need to access here. Right? And let's talk about the store and forward technology. All right, and in the OPC server or the MQTT broker, you have a Canary collector installed, and then that is come together with the Canary collector is what they call it is called standard service that push the data from the OPC server and then pushes it across to the network to the receiver service that is resided in the historian. All right, and message is received and written to the database. Okay, if any of the reason that the network is disconnected, all right, all the data will be cached locally on the OPC server with the Canary collector and notifies the admin. It will actually notify the admin to telling him that there is a disconnection happen and do the necessary action that required. It could be the network issue, it could be the switch issue, on the network system. And when the network connection is established again, automatically data will be backfills, right? So there is no kind of what we call that a situation there the data will be lost. And The system also allows you to do a dual logging and sending data from one standard to multiple receiver of the historian. So you can imagine that the data is collected and pushed into two different Canary historian or the times used database in this scenario. Or it could be even allows you to send in the data to multiple architecture that you are currently seeing. Yeah. Okay. And when it comes to the Canary historian, it's a NoSQL time series database. So what is the benefit of NoSQL is that you don't have to do any maintenance, basically. All right. It specifically built and optimized for process and data performance. And of course, as I mentioned earlier, no DBA skill set is required. Okay. It's very scalable. It could be starting from 100 and even up to 2 million tags. And it connect local historian to corporate historian. It could be supporting the dual logging, as I mentioned earlier, or you could even the mirror service, right? And as you can see in the diagram, that there is within the architecture, the mirror service on the corporate historian, all right, on the corporate historian pulls the data on SCADA and can save on the bandwidth, right? And you can see here the mirror service on corporate historian puts the data on schedule, so you don't have to be like a real time, and actually taking up all your bandwidth. So you can have a different sites, that consolidate into different location. Okay. And importantly, that regardless how is the size going to grow, the performance does not degrade over time, right? And we're talking about 1.5 million writes over second and 2.5 million reads over second. Right, and if you look at here, what I'm going to show you on this video is that we have a 1 million tags being captured, from 4 different site equipment. And as you can see here is that you can see that there's a 250,000, all right, 250,000 the data being captured on these 4 equipments. Yeah, and importantly, what I'm going to show here is that each machine is sending 250,000 tags over here. Yeah, it's 250,000. And what I'm going to show here is that to tell you that how much the processors and memory actually utilizing. And importantly is that now we are talking about writing 1 million objects in seconds. And you look at later on, if you look at the memory or the processor, it doesn't really spike, okay, that much. Okay, so in another meaning is that you don't have to have a very high still of kind of a system or a supercomputer to really run the Canary historian. Okay, as you can see here, look at that. This is the system that we are having on the Canary historian, and look at the memory, 31 gig. We are just merely using 54%, more than a bit half than the 50%. And basically, we don't see any there. The utilization of memory or the processor doesn't really spike. Okay. And what is tag? Okay, tag is a single stream of time series data, also referred to as a points, channels, or items. So it depends on which industry coming from. A tag consists of a TDQ, which is comprised of timestamp, value, quality. Okay. And then metadata properties is those are engineering units or terms, such as high low set points, GPS coordinates, and it can be fully customizable data properties into those data is collected. You have a lossless compression algorithm, best in the performance, and 3 times of the data compression. Because it's lossless, we never interpolating the data, okay, never cutting data values. The unique raw values are being stored every time, okay. And out of the box ready, okay, no data loss. You don't have to do a lot of customization required, and there's no data loss because of the store forward technology that I mentioned to you about Canary Connector. And ultimately, Canary create a database that you can always depend on. So it's a very reliable historian or database system. Okay. So that is the end of the step one. So the data is being collected, and then how do we actually really make it become meaningful? All right. So in Canary, we have it coming into what we call is virtual views. So we have in a history, let's say this is an example that what we are seeing here. You have one piece of equipment here on the line one with different naming structures. And we have also another, line two equipment with a different naming structure. So for the engineers, of course, in the operational, you don't have anything that is going to impacting to the to the operational, all right? But in terms of like you want to view or do a reporting and relook and learn or do a trending to it using this data, the engineers have to remember all these contacts, and it is very difficult to do so. So of course, from the client perspective, from the engineer perspective, they will want to look at like the desired client format, where it provides a more meaningful, such as line number will be the representing the location of it, and then the equipment or the tag boiler, and also finally is the engineering term or the units. Okay, and virtual views are created on top of historian. So this is an architecture, how it looks like. You have a backend of the Canary historian, you have a calculation engine, and you have in the middle there is a views, and finally the events. And the views is actually a filter of information of the text that is before they being viewed by the client. All right. So you can create a multiple different view to a different client. Okay. So that is relevant to them. Okay, so we have an example here how the virtual view can really assign context to your data. Inside the historian, you can have this 10 pieces of IO, So we're going to apply a virtual view and how the client see the unified name spacing. All right. So this is how it looks like. We want to have like a unique identifier as a location, which is line one, and then after that, then the tag, and finally the units. And if you go to the line two, we are seeing the same thing. Just the difference is that it's the same format, but the tag retains the uniqueness. All right. And you go back again and come back again. You see there is always that the information change is always on the location, right? Which is represented or the what I call the equipment, which is represented by the line. Okay. And what else we can do with it? All right. Once text has been structured and unified in the namespace, we can establish a custom asset model. All right. So we have what we have here is that we have a tree site here, a tree line here. Okay, we have a tree line here, and then on the line number one we have one boiler, and the line number two we have one boiler, and the line number three we also have going to have two boilers. All right. So looking at the example, that the four boilers on the line one, on the line two, and line three. Let's see how it works. All right. So what happens is that, okay, in this example, we have a line one. All right. After we unify the naming, we have a line one boiler one, and we have a line two boiler one, we have a line three boiler one, and line three boiler two. All right. And common technique with the unit element is exactly where the asset, what else to impact. So why is it so beneficial of us doing so? All right, because the client can request the data based on the asset, right? It can based on the asset, and it show all the boiler's temperature, okay, or filtering based on data asset type condition. Like I want to show all boilers with the temperature more than 220 Fahrenheit, okay. And the next thing is that is about the virtual view. All right. And another one is that the calculation engine. All right. And if you think about a car, that's what it's feeding you with raw, process data, how fast I'm driving, how many miles are on the odometer. All right, those are raw data, and how much fuel is left in the tank. That's all raw data. Okay, and then the second thing is that if you check engine light is on, there is a condition-based data. Okay, and finally, it's a calculated KPI. You know, a lot of cars have already indicated a range how many miles that you can travel with available gas in the tank. You look at those different types of data, especially in the historian, we have a raw data. But if this data, we group it together and we can create rules, you know, and calculating the KPI, which is the range, how much more that we can travel with available tank with the current speed. All right, that is what we call a calculated KPI. Okay, a single calculation can be deployed in all instances of asset type. It runs in real time while backfilling, and more than 70 functions available in the Canary. Okay, so if you look at our asset tag of a boiler, you can see there is a temperature tag. Every 5 seconds or 1 second, the boiler will get a new temperature. We could run a calculation at any time there's a boiler to us to use temperature tag that given us an average 60 minutes temperature for the tag. For the fueler, we could use out bottle count and out bottles rejected to determine the percentage of the rejected bottle. All right, so this is what we can do using the calculation engine. And finally, in the assign of data context, is can be condition-based asset monitoring. Okay, and reporting based on event performance, analytics around the event duration. Okay, how does it do so? Okay, let's see there is a construction rule is the trigger for an event. A simple rule would be to start an event if the level of a tank gets below 25% and the temperature of the liquid gets below 80 degrees. Okay, so this is what is the data that we are running this event. This is what the data that we are getting. All right, so this is a list of the instances of events within the condition we have structured each of the various sites. Okay. And let's wrap up the second step. So we have collected data, assigned to your data with a context that meaningful, and finally maximize your operation. All right, maximize operation. As I mentioned earlier, that this whole webinar is talking about visualization of your process data and using the visualization tools. So this is a key thing. So it comes into 3 points. One is a Axiom. All right. It's basically to design to do a tracking, dashboarding, and also is a reporting tool. All right, it's built in HTML within any modern web browser, basically. Yeah, so almost any devices, I can say. Designed for self-serve reporting because it changes the traditional model of the client asking SCADA team, to produce a trend chart. It makes it easy for the end user to produce their own trend chart, so you don't have to get someone else to help you. Please, can you help me to produce the report to me? So it's kind of like you give it, to the client or to the user to do the self-serve reporting. All right. So this is, as you can see, the data have been, example of a chart that we produce in Axiom. All right. And also over here, you can even add in things like donut gouges or plug lines, and then you have the numbers which are representing the numbers that captures from the tag, all right, from the equipment. So yeah, and then of course that you can see that you can build an application that less about trend lines and more about looking at the data. Tables or graph. It's completely blank slate, which allows you to customize and build out whatever you need to visualize. You will see this in if let's say that for example, you have some good idea on how you do a designing or more creative kind of mind, you probably can create this within a couple of hours. Of course, that a person like me, which is very low, in terms of creativity, then probably you need to take days. But I guess that for most of you, you can take within a couple of hours that you can build up something very nice and complex dashboarding using the Axiom. Okay. Yeah, so you can see that is also, this is another one that is how does it incorporate trend charts and also tables of data come into together, all right? And as it also can be used with a build application that less about, a completely, sorry, yeah. Okay, so you can even put in what I call that, a CCTV to embed it into the real kind of environment, looking at the warehouse, for example, in this example, or you can real time monitoring the machines or the equipment. So it is a very what I call an interactive way how you can design your dashboard or your trending chart, okay, easily. All right. And of course, there is when it comes into we know that many of your team members are already using Excel, so this Excel add-in is that to connect the Canary to your Excel, and it will quickly, to help to address your reporting needs. Okay, where you can immediately get into the Canary database and retrieve it out into your Excel. Okay, and it could be ad hoc event monitoring as well. You can build an ad hoc event monitoring on the fly. Okay, using the Canary Excel add-in. And yeah, this is how it look like. You go from the Excel after you install the add-in. You will get what I call that, a tools on the top where you can connecting directly to the Canary database. So you just type in what filter that you want to look at, and by doing that, and then you click on the last value, and you can apply on it, right? So immediately things are actually emerge on the screen, and then it's ready for your reporting purposes. Okay, so it was such a very simple tool that it almost like any organization that you need to do a reporting, then probably this is going to help you, right? And finally, there's a Canary Connectors, all right, that you need to connecting to the other databases, or they are other type of what I call that standard. It could be a published service using a web API, either you're using a SCADA connectors, an ODBs connector. You need to expose Canary stored in a SQL-like manner to make queries against our databases, or it could be OPC HDN servers speaking directly to our historian. So we have all these connectors ready. All right. All right, that just wraps up on the three steps how actually Canary can help you on your journey to the digital transformation. Now we will, okay, and the Canary system. All right, we have Canary, and overall, what we've been discussed before. We have a Canary collector, store and forward, Canary history, include 100 tags, virtual view. So all this could be easily to customize your own system, all right? And you can get the pricing. And one thing good about the Canary is that our pricing is open, all right? We don't like kind of like doing markup on ourselves, but because the pricing is all available on the lab, right? So you can immediately go into it, and then you can look at the pricing. And shall you have any questions, always welcome to promise, all right? Okay, so yep, that's it for today. If any questions, please you could raise it to us. I know, raise it to me. I am more than helpful to to help to address your question. Okay. So any questions so far that you would like to ask? Probably you can type it on the questions. Anyway, if you don't, we don't have questions, then we call it for today. And if you have any questions, please welcome to drop me an email, and we always, more than happy to help you all. And thanks again for everyone for joining me today. And we should all have a good weekend ahead. Thank you.